Hello students, once again Mr. Hatfield here to demonstrate a one-step conversion factor problem where we're going to use fractional setups with cancellation. Previously we did moles to grams or grams to moles. To do those conversions we get the molar mass from the periodic table. We also did moles to particles or particles to moles where we have 1 mole of substance is always equal to that large number, Avogadro's number, 6.02 times 10 to the 23rd. So that was our conversion factor. Now we're going to do the molar volume. The molar volume is a special case where we pretend that we're looking at a gas. And at certain conditions, a gas will occupy a volume which is roughly about this big, a cube about this dimension, about 22.4 liters. And so we are going to use that number, 22.4 liters per mole, as our conversion factor because we're assuming STP. STP means standard temperature and pressure. The standard temperature and pressure is 0 degrees Celsius, which is the freezing point of water, and 1 atmosphere, which is roughly the pressure of the atmosphere at sea level. Later on, when we do a unit on gas laws, we'll learn how to handle situations where we actually are using the real temperature and the real pressure. But right now, just to simplify things, we're just going to use the molar volume, 22.4 liters per mole at STP, and that will become our automatic conversion factor. Other than that, these problems work exactly the same way as any other problem. So let's first do, say, water vapor. There's water vapor in the atmosphere. So let's say that we have 12 liters of water vapor. So we write 12 liters, number, unit, and substance. The number is 12, the unit is liters, the substance is water, H2O. And we just want to know how many moles that is. Okay, well, we're assuming that it's at STP, standard temperature and pressure. Since we have liters of water at the top of the first expression, we're going to have that liters down here. And since we're saying that this is gas, water vapor, then this number, 22.4 liters, comes into play. So we put that 22.4 liters here. It's just 1 mole of water on the top because, right, 22.4 liters is 1 mole at STP. And now it should be obvious that our liters of water will cancel. A calculator comes in handy. And so this is just going to be 12 divided by 22.4. And we get this number, roughly 0.54 moles of H2O. Liters to moles. The liters cancels out. But suppose instead of giving us liters that some wise guy says, oh, I know I have a certain amount of moles and I want you to tell me what that is. Well, okay, let's try that out. Instead of 12 liters of water, let's say that we've got, I don't know, 3 moles of water. And we write that as a fraction over 1. The number is 3, the unit is moles, the substance is water, H2O. All right, so we're still saying it's an STP. Since we have moles of water on top of the first expression, we're going to have that mole of water on the bottom of the second. It's just 1 mole. And if you have 1 mole at STP, you have 22.4 liters of that water. So we put 22.4 liters of water on top. Our moles of water will cancel. This just becomes 3 times 22.4, which is 67.2 liters of water. Number, unit, and substance. Now, in each of the videos that I've made in the first part of this unit, I've focused just on one-step conversions. But if we look at our flow chart, it should be pretty clear that we could go from grams to moles to particles, or we could go from grams to moles to liters, or we could go from liters to moles to particles, or liters to moles to grams. We would just, instead of having 1 conversion factor, we'd have 2 in a row. Instead of canceling out 1 unit for substance, we'd cancel out 2. So the mole really does act like a bridge that allows us to connect different quantities and solve these problems in chemistry. I hope you find that very helpful.